The Panavia Tornado is a family of twin-engine, variable sweep-wing combat aircraft, which was jointly developed and manufactured by Italy, the United Kingdom, and West Germany. There are three primary Tornado variants. The Tornado IDS fighter bomber, the suppression of enemy air defenses Tornado ECR and the Tornado ADV interceptor aircraft. The Tornado was developed and built by Panavia Aircraft GmbH, a tri-national consortium consisting of British Aerospace, MBB of West Germany, and Aeritalia of Italy. It first flew on August 14, 1974 and was introduced into service in 1979–1980. Due to its multirole nature, it was able to replace several different fleets of aircraft in the adopting air forces. The Royal Saudi Air Force became the only export operator of the Tornado in addition to the three original partner nations. A tri-nation training and evaluation unit operating from RAF Cottesmore, the tri-national Tornado training establishment, maintained a level of international cooperation beyond the production stage. The Tornado was used by the Royal Air Force, Italian Air Force and RSAF during the 1991 Gulf War, in which the Tornado conducted many low-altitude penetrating strike missions. The Tornadoes of various operators were also used in conflicts in the former Yugoslavia during the Bosnian War and Kosovo War, the Iraq War, Libya during the Libyan Civil War, as well as smaller roles in Afghanistan and Yemen. Including all variants, 992 aircraft were built. Development, origins. During the 1960s, aeronautical designers looked to variable geometry wing designs to gain the maneuverability and efficient cruise of straight wings with the speed of swept wing designs. The United Kingdom had cancelled the procurement of the TS-2 and subsequent F-111K aircraft, and was still looking for a replacement for its Avro Vulcan and Blackburn Buccaneer strike aircraft. Britain and France had initiated the AFVG project in 1965. But this had ended with French withdrawal in 1967. Britain continued to develop a variable geometry aircraft similar to the proposed AFVG, and sought new partners in order to achieve this. In 1968, West Germany, the Netherlands, Belgium, Italy and Canada formed a working group to examine replacements for the Lockheed F-104 Starfighter, initially called the multirole aircraft, later renamed as the multirole combat aircraft. The participating nations all had aging fleets that required replacing. But, as the requirements were so diverse, it was decided to develop a single aircraft that could perform a variety of missions that were previously undertaken by a fleet of different aircraft. Britain joined the MRCA group in 1968, represented by Air Vice Marshal Michael Giddings, and a memorandum of agreement was drafted between Britain, West Germany, and Italy in May 1969. By the end of 1968, the prospective purchases from the six countries amounted to 1,500 aircraft. Canada and Belgium had departed before any long-term commitments had been made to the program. Canada had found the project politically unpalatable. There was a perception in political circles that much of the manufacturing and specifications were focused on Western Europe. France had made a favorable offer to Belgium on the Dassault Mirage 5. Which created doubt as to whether the MRCA would be worthwhile from Belgium's operational perspective. Panavia Aircraft GmbH. On March 26, 1969, four partner nations United Kingdom, Germany, Italy and the Netherlands, agreed to form a multinational company, Panavia Aircraft GmbH, to develop and manufacture the MRCA. The project's aim was to produce an aircraft capable of undertaking missions in the tactical strike, reconnaissance, air defense, and maritime roles, thus allowing the MRCA to replace several different aircraft then in use by the partner nations. Various concepts, including alternative fixed-wing and single-engine designs, were studied while defining the aircraft. The Netherlands pulled out of the project in 1970, citing that the aircraft was too complicated and technical for the RNLAF's preferences, which had sought a simpler aircraft with outstanding maneuverability. An additional blow was struck by the German requirement reduced from an initial 600 aircraft to 324 in 1972. When the agreement was finalized, The United Kingdom and West Germany each had a 42.5% stake of the workload, with the remaining 15% going to Italy. This division of the production work was heavily influenced by international political bargaining. The front fuselage and tail assembly was assigned to BAC in the United Kingdom, the center fuselage to MBB in West Germany, and the wings to Aeritalia in Italy. Similarly, tri-national work sharing was used for engines, general and avionic equipment. A separate multinational company, Turbo Union, was formed in June 1970 to develop and build the RB199 engines for the aircraft, with ownership similarly split 40% Rolls-Royce, 40% MTU, and 20% Fiat. At the conclusion of the project definition phase in May 1970, the concepts were reduced to two designs. A single-seat Panavia 100 which West Germany initially preferred, and the twin-seat Panavia 200 which the RAF preferred and which would become the Tornado. The aircraft was briefly called the Panavia Panther. The project soon coalesced towards the two-seat option. In September 1971, the three governments signed an intention to proceed document, at which point the aircraft was intended solely for the low-level strike mission, where it was viewed as a viable threat to Soviet defenses in that role. It was at this point that Britain's Chief of the Defence Staff announced two-thirds of the fighting frontline will be composed of the single, basic aircraft type. Prototypes and testing. The first of more than a dozen Tornado prototypes took flight on August 14, 1974 at Manching, Germany. The pilot, Paul Millett, stated of the incident, "Aircraft handling was delightful. The actual flight went so smoothly that I did begin to wonder whether this was not yet another simulation." Flight testing led to the need for minor modifications. Airflow disturbances were responded to by reprofiling the engine intakes and the fuselage to minimize surging and buffeting experienced at supersonic speeds. Testing revealed that a nose-wheel steering augmentation system, connecting with the yaw damper, was necessary to counteract the destabilizing effect produced by deploying the thrust reverser during landing rollouts. In August 1976, Soviet espionage activities were exposed trying to obtain information on the aircraft. Two prototypes were lost in accidents, both of which had been primarily caused by poor piloting decisions and errors leading to two ground collision incidents. A third Tornado prototype was seriously damaged by an incident involving pilot-induced pitch oscillation. The Tornado made use of relatively new electronic technologies to stabilize the aircraft's flight and augment its flight envelope, known as active control technology or fly-by-wire. Thus several older aircraft types were extensively converted and rebuilt for testing to establish the concept's validity. In the late 1970s, British Aerospace developed a technology demonstration aircraft, a converted Suppression Jaguar, equipped with a full-authority digital flight control system, with progressive changes to the airframe to showcase the system's ability to compensate for aerodynamic irregularities and imbalances. MBB also flew a converted demonstrator aircraft, a Lockheed F-104G Starfighter, which similarly compensated for instability via a digital flight control system. Experience from both of these programs would influence the Tornado, and to a greater extent, the later Eurofighter Typhoon. Production. The contract for the Batch 1 aircraft was signed on July 29, 1976. The first aircraft were delivered to the RAF and German Air Force on 5 and 6 June 1979 respectively. The first Italian Tornado was delivered on September 25, 1981. On January 29, 1981, the tri-national Tornado training establishment officially opened at RAF Cottesmore, remaining active and training pilots from all operating nations until March 31, 1999. The 500th Tornado to be produced was delivered to West Germany on December 19, 1987. Export customers were sought after West Germany withdrew its objections to exporting the aircraft. Saudi Arabia was the only export customer of the Tornado. The agreement to purchase the Tornado was part of the controversial Al Yamama arms deal between BAE Systems and the Saudi government. Oman had committed to purchasing Tornadoes and the equipment to operate them for a total value of £250 a million in the late 1980s, but cancelled the order in 1990 due to financial difficulties. During the 1970s, Australia considered joining the MRCA program to find a replacement for their aging Dassault Mirage IIs. Ultimately, the McDonnell Douglas FA-18 Hornet was selected to meet the requirement. Canada similarly opted for the FA-18 after considering the Tornado. Japan considered the Tornado in the 1980s, along with the General Dynamics F-16 Fighting Falcon and FA-18. Before selecting the Mitsubishi F-2, a domestically produced design based on the F-16. In the 1990s, both Taiwan and South Korea expressed interest in acquiring a small number of Tornado ECR aircraft. In 2001, EADS proposed a Tornado ECR variant with a greater electronic warfare capability for Australia. Production came to an end in 1998. The last batch of aircraft being produced going to the Royal Saudi Air Force, who had ordered a total of 96 IDS Tornadoes. In June 2011, it was announced that the RAF's Tornado fleet had flown collectively over 1 million flying hours. Aviation author John Lake noted that the National Panavia consortium produced just short of 1,000 Tornadoes, making it one of the most successful post-war bomber programs. In 2008, Air Forces Monthly said of the Tornado, for more than a quarter of a century, the most important military aircraft in Western Europe. Design overview: the Panavia Tornado is a multirole, twin-engined aircraft designed to excel at low-level penetration of enemy defenses. The mission envisaged during the Cold War was the delivery of conventional and nuclear ordnance on the invading forces of the Warsaw Pact countries of Eastern Europe. This dictated several significant features of the design. Variable wing geometry, allowing for minimal drag during the critical low-level dash towards a well-prepared enemy, had been desired from the project start. Advanced navigation and flight computers, including the then innovative fly-by-wire system, greatly reduced the workload of the pilot during low-level flight and eased control of the aircraft. For long-range bombing missions, the Tornado has a retractable refueling probe. As a multi-role aircraft, the Tornado is capable of undertaking more mission profiles than the anticipated strike mission. Various operators replaced multiple aircraft types with the Tornado as a common type. The use of dedicated single-role aircraft for specialist purposes such as battlefield reconnaissance, maritime patrol duties, or dedicated electronic countermeasures were phased out. Either by standard Tornadoes or modified variants, such as the Tornado ECR. The most extensive modification from the base Tornado design was the Tornado ADV, which was stretched and armed with long-range anti-aircraft missiles to serve in the interceptor role. The Tornado operators have chosen to undertake various life extension and upgrade programs in order to keep their Tornado fleets as viable frontline aircraft for the foreseeable future. The RAF and RSAF have upgraded their Tornadoes to the GR4 standard to increase combat effectiveness, while German Tornadoes have been undergoing periodic upgrades under the multi-stage ASSTA program. With these upgrades, as of 2011, it is projected that the Tornado shall be in service until 2025, more than 50 years after the first prototype took flight. Variable sweep wing. In order for the Tornado to perform well as a low-level supersonic strike aircraft, it was considered necessary for it to possess good high-speed and low-speed flight characteristics. To achieve high-speed performance, a swept-wing or delta-wing planform is typically adopted, but these wing designs are inefficient at low speeds. To operate at both high and low speeds with great effectiveness, the Tornado uses a variable sweep wing. This approach had been adopted by earlier aircraft, such as the American General Dynamics F-111 Aardvark strike fighter, and the Soviet Mikoyan Gurevich MiG-23 fighter. The F-111 has many similarities with the smaller Tornado. However, the Tornado differs in being a multi-role aircraft with more advanced onboard systems and avionics. The level of wing sweep, the angle of the wings in relation to the fuselage, can be altered in flight at the pilot's control. The variable wing can adopt any sweep angle between 25 degrees and 67 degrees, with a corresponding speed range for each angle. Some Tornado ADVs were outfitted with an automatic wing sweep system to reduce pilot workload. When the wings are swept back, the exposed wing area is lowered and drag is significantly decreased, which is conducive to performing high-speed low-level flight. The weapons pylons pivot with the angle of the variably Euro-sweep wings so that the stores point in the direction of flight and do not hinder any wing positions. In development, significant attention was given to the Tornado's short-field takeoff and landing performance. Germany, in particular, encouraged this design aspect. For shorter takeoff and landing distances, the Tornado can sweep its wings forwards to the 25-degree position, and deploy its full-span flaps and leading-edge slats to allow the aircraft to fly at slower speeds. These features, in combination with the thrust reverser-equipped engines, gives the Tornado excellent low-speed handling and landing characteristics. Avionics. The Tornado features a tandem-seat cockpit, crewed by a pilot and a navigator weapons officer. Both electromechanical and electro-optical controls are used to fly the aircraft and manage its systems. An array of dials and switches are mounted on either side of a centrally placed CRT monitor, controlling the navigational, communications, and weapons control computers. BAE Systems developed the Tornado Advanced Radar Display Information System, a 32.5 cm multifunction display, to replace the rear cockpit's combined radar and projected map display. The RAF began installing TARDIS on the GR4 fleet in 2004. The primary flight controls of the Tornado are a fly-by-wire hybrid, consisting of an analog quadruplex command and stability augmentation system connected to a digital autopilot and flight director system. In addition, a level of mechanical reversion capacity was retained to safeguard against potential failure. To enhance pilot awareness, artificial feel was built into the flight controls, such as the centrally located stick. Because of the Tornado's variable wings enabling the aircraft to drastically alter its flight envelope, the artificial responses adjust automatically to wing profile changes and other changes to flight attitude. As a large variety of munitions and stores can be outfitted, the resulting changes to the aircraft's flight dynamics are routinely compensated for by the flight stability system. The Tornado incorporates a combined navigation attack Doppler radar that simultaneously scans for targets and conducts fully automated terrain following for low-level flight operations. Being readily able to conduct all-weather hands-off low-level flight was considered one of the core advantages of the Tornado. The Tornado ADV has a different radar system to other variants, designated AI-24 Foxhunter, as it is designed for air defense operations. It is capable of continuously keeping track of up to 20 targets at ranges of up to 160 kilometers. The Tornado was one of the earliest aircraft to fitted with a digital data bus for data transmission. A Link 16J TIDS integration on the F3 variant enabled the exchange of radar and other sensory information with nearby friendly aircraft. Some Tornado variants carry different avionics and equipment, depending on their mission. The Tornado ECR is devoted to suppression of enemy air defenses missions, operated by Germany and Italy. The Tornado ECR is equipped with an emitter-locator system to spot radar use. German ECRs have a Honeywell infrared imaging system for reconnaissance flights. RAF and RSAF Tornadoes have the laser rangefinder and mark target seekers for targeting laser-guided munitions. In 1991, the RAF introduced TIALD, allowing Tornado GR-1S to laser designate their own targets. The GR-1A and GR-4A were equipped with TIRRS, consisting of one SLIR sensor on each side of the fuselage forward of the engine intakes to capture oblique images, and a single IRLS sensor mounted on the fuselage's underside to provide vertical images. TIRRS recorded images on 6 SVHS videotapes. The newer Raptor reconnaissance pod has replaced the built-in TIRRS system. Armament and equipment. The Tornado is cleared to carry the majority of air-launched weapons in the NATO inventory, including various unguided and laser-guided bombs, anti-ship and anti-radiation missiles, as well as specialized weapons such as anti-personnel mines and anti-runway munitions. In order to improve survivability in combat, The Tornado is equipped with onboard countermeasures, ranging from flare and chaff dispensers to electronic countermeasure pods that can be mounted under the wings. Underwing fuel tanks and a body store aerial refueling system that allows one Tornado to refuel another are available to extend the aircraft's range. In the decades since the Tornado's introduction, all of the Tornado operators have undertaken various upgrade and modification programs to allow recently introduced weapons to be used by their squadrons. Amongst the new armaments that the Tornado has been adapted to deploy are the enhanced paveway and joint direct attack munition bombs, and modern cruise missiles such as the Taurus and Storm Shadow missiles. These upgrades have increased the Tornado's capabilities and combat accuracy. Precision weapons such as cruise missiles have replaced older munitions such as cluster bombs. Strike variants have a limited air-to-air capability with AIM-9 Sidewinder or AIM-132 ASRAAM air-to-air missiles. Additionally, the Tornado ADV is outfitted with beyond visual range AAMs such as the Scaflash and AIM-120 AMRAAM missiles. The Tornado is armed with two 27mm Mauser BK-27 revolver cannon internally mounted underneath the fuselage. The Tornado ADV was only armed with one cannon. When the RAF GR-1 aircraft were converted to GR-4, the FLIR sensor replaced the left-hand cannon, leaving only one. The GR-1A reconnaissance variant gave up both its guns to make space for the sideways-looking infrared sensors. The Mauser BK-27 was developed specifically for the Tornado, but has since been used on several other European fighters, such as the Dassault Dornier Alpha Jet, Saab JAS-39 Gripen, and Eurofighter Typhoon. The Tornado is capable of delivering air-launched nuclear weapons. In 1979, Britain considered replacing its Polaris submarines with either the Trident submarines or alternatively the Tornado as the main bearer of its nuclear deterrent. Although the UK proceeded with Trident, several Tornado squadrons based in Germany were assigned to SACEUR to deter a major Soviet offensive with both conventional and nuclear weapons, namely the WE-177 nuclear bomb, which was retired in 1998. German and Italian Tornadoes are capable of delivering USB-61 nuclear bombs, which are made available through NATO. Engine. Britain considered the selection of Rolls-Royce to develop the advanced engine for the MRCA to be essential, and was strongly opposed to adopting an engine from an American manufacturer, to the point where the UK might have withdrawn over the issue. In September 1969, Rolls-Royce's AB199 engine was selected to power the MRCA. One advantage over the US competition was that a technology transfer between the partner nations had been agreed. The engine was to be developed and manufactured by a joint company, Turbo Union. The program was delayed by Rolls-Royce's entry into receivership in 1971. The nature of the multinational collaboration process helped avoid major disruption of the Tornado program. Research from the supersonic airliner Concorde contributed to the development and final design of the AB199 and of the engine control units. To provide the desired performance, several features were used in the AB199. To operate efficiently across a wide range of conditions and speeds up to Mach 2, the AB199 and several other engines make use of variable intake ramps to control the airflow. The hydraulic system is pressurized by siphoning power from both or either operational engine. The hydraulics are completely contained within the airframe rather than integrating with the engine to improve safety and maintainability. In case of double engine, or double generator, failure, the Tornado has a single-use battery capable of operating the fuel pump and hydraulics for up to 13 minutes. Relatively rare amongst fighter aircraft, the AB199 is fitted with thrust reversers to decrease the distance required to safely land. To fully deploy the thrust reverser during landings, the yaw damper is connected to the steering of the nose wheel to provide greater stability. In August 1974, the first AB199-powered flight of a prototype Tornado occurred. The engine completed its qualification tests in late 1978. The final production standard engine met both reliability and performance standards, though the development cost had been higher than predicted, in part due to the ambitious performance requirements. At the time of the Tornado's introduction to service, the turbine blades of the engine suffered from a shorter lifespan than desired, which was rectified by the implementation of design revisions upon early production engines. Several uprated engines were developed and used on both the majority of Tornado ADVs and Germany's Tornado ECRs. Upgrades: being designed for low-level operations, the Tornado required modification to perform in medium-level operations that the RAF adopted in the 1990s. The RAF's GR1 fleet was extensively remanufactured as Tornado GR4S. Upgrades on Tornado GR4S included EFLIR, a wide-angle HUD, improved cockpit displays, NVG capabilities, new avionics, and a global positioning system receiver. The upgrade eased the integration of new weapons and sensors which were purchased in parallel, including the Storm Shadow cruise missile, the Brimstone anti-tank missile, Paveway 3 laser-guided bombs, and the Raptor reconnaissance pod was integrated. The first flight of a Tornado GR4 was on April 4, 1997. On October 31, 1997, the RAF accepted the first delivery and deliveries were completed in 2003. In 2005, the RSAF opted to have their Tornado IDSs undergo a series of upgrades to become equivalent to the RAF's GR4 configuration. On December 21, 2007, BAE signed a £210 million contract for CASP, the Capability Upgrade Strategy. This project would see RAF GR4/4A improved in two phases, starting with the integration of the Paveway 4 bomb and a communications upgrade, followed by a new tactical data link in Phase B. Beginning in 2000, German IDS and ECR Tornadoes received the ASSTA-1 upgrade. ASSTA-1 involved a replacement weapons computer, new GPS and laser inertial navigation systems. The new computer allowed the integration of the HARM-3, HARM-0 Block 4V and Taurus KEPD 350 missiles, the RAF AR Lightning II laser designator pod and GBU-24 Paveway 3 laser-guided bombs. The ASSTA-2 upgrade began in 2005, primarily consisting of several new digital avionics systems, a new ECM suite and provision for the Taurus cruise missile. These upgrades are to be only applied to 85 Tornadoes, as the Tornado is in the process of being replaced by the Eurofighter Typhoon. The ASSTA-3 upgrade program, started in 2008, will introduce support for the laser-targeted Joint Direct Attack munition along with further software changes. Test platform for 3D printed parts. BAE Systems announced that, in December 2013, the company had test-flown a Tornado equipped with parts that were made with 3D printing equipment. The parts included a protective cover for the radio, a landing gear guard and air intake door support struts. The test demonstrated the feasibility of making replacement parts quickly and cheaply at the airbase hosting the Tornado. The company claims that, with some of the parts costing less than £100 per piece to manufacture, 3D printing has already resulted in savings of more than £300,000 and will offer further potential cost savings of more than £1.2 million between now and 2017. Operational history: German Air Force. The first Tornado prototype made its first flight on August 14, 1974 from Manching Air Base, in what was then West Germany. Deliveries of production Tornadoes began on July 27, 1979. The total number of Tornadoes delivered to the German Air Force numbered 247, including 35 ECR variants. Originally Tornadoes equipped 5 fighter bomber wings, with 1 tactical conversion unit and 4 frontline wings, replacing the Lockheed F-104 Starfighter. When one of the 2 Tornado wings of the German Navy was disbanded in 1994, its aircraft were used to re-equip a Luftwaffe's reconnaissance wing formerly equipped with RF-4E Phantoms. As many as 15 German Tornadoes undertook combat operations as a part of NATO's campaign during the Bosnian War. This was the first combat operation for the Luftwaffe since World War II. The Tornadoes, operating from Piacenza, Italy, flew reconnaissance missions to survey damage inflicted by previous strikes and to scout targets for other aircraft to strike. These reconnaissance missions were reportedly responsible for a significant improvement in target selection throughout the campaign. In 1999, German and Italian Tornadoes participated in Operation Allied Force, NATO's military operation against the Federal Republic of Yugoslavia during the Kosovo War. The ECR aircraft would escort various Allies' aircraft while carrying several AGM-88 HARM missiles to counter attempted use of radar against the Allied aircraft. During the Kosovo hostilities, Germany's IDS Tornadoes would routinely conduct reconnaissance flights to identify both enemy ground forces and civilian refugees within Yugoslavia. In June 2007, a pair of Luftwaffe Tornado were controversially used to fly reconnaissance flights over an anti-globalization demonstration during the 33rd G8 summit in Heiligendamm. Following the mission, the German Defense Ministry admitted one aircraft had broken the minimum flying altitude and that mistakes were made in the handling of security of the summit. In 2007, a detachment of 6 Tornadoes of the AUFKLA currency Runggeschwader 51 Immermann were deployed to Mazar-i-Sharif, northern Afghanistan, to support NATO forces. The decision to send Tornadoes to Afghanistan was a controversial decision, including one political party launching an unsuccessful legal bid to block the deployment as unconstitutional. In support of the Afghanistan mission, improvements in the Tornadoes' reconnaissance equipment were accelerated, improving the Tornado's ability to detect hidden improvised explosive devices. The German Tornadoes were withdrawn from Afghanistan in November 2010. Defense cuts announced in March 2003 resulted in the decision to retire 90 Tornadoes from Luftwaffe service. This led to a reduction in its Tornado strength to 4 wings by September 2005. On January 13, 2004, the then-German Defense Minister Peter Strzok announced further major changes to the German armed forces. A major part of this announcement is the plan to cut the German fighter fleet from 426 in early 2004 to 265 by 2015. The German Tornado forces to be reduced to 85, with the type expected to remain in service with the Luftwaffe until 2020. The aircraft being retained have been undergoing a service life extension program. German Navy. In addition to the order made by the Luftwaffe, the German Navy's Marine Flieger also received 112 of the IDS variant in the anti-shipping and marine reconnaissance roles, again replacing the Starfighter. These equipped 2 wings, each with a nominal strength of 48 aircraft. The principal anti-ship weapon was the AS-34 Cormoran anti-ship missile, which were initially supplemented by unguided bombs and BL-755 cluster bombs, and later by AGM-88 HARM anti-radar missiles. Pods fitted with panoramic optical cameras and an infrared line scan were carried for the reconnaissance mission. The end of the Cold War and the signing of the CFE Treaty gave rise to a requirement for Germany to reduce the size of its armed forces, including the number of combat aircraft. To meet this need, one of the Marine Flieger's Tornado wings was disbanded on January 1, 1994. Its aircraft replaced the Phantoms of a Luftwaffe reconnaissance wing. The second wing was enlarged and continued in the anti-shipping, reconnaissance and anti-radar roles until it was disbanded in 2005 with its aircraft and duties passed on to the Luftwaffe. Italian Air Force. The first Italian prototype made its maiden flight on December 5, 1975 from Turin, Italy. The Aeronautica Militare received a total of 100 Tornado IDS. 16 IDSs were subsequently converted to the ECR configuration. The first Italian Tornado ECR was delivered on February 27, 1998. As a stopgap measure for 10 years, the Aeronautica Militare additionally operated 24 Tornado ADVs in the air defense role, which were leased from the RAF to cover the service gap between the retirement of the Lockheed F-104 Starfighter and the introduction of the Eurofighter Typhoon. In 2000, with major delays hampering the Eurofighter, the Aeronautica Militare began a search for another interim fighter. While the Tornado itself was considered, any long-term extension to the lease would have involved upgrade to a RAF CSP standard and thus was not considered cost-effective. In February 2001, Italy announced its arrangement to lease 35 F-16s from the United States. the Aeronautica Militare returned its Tornado ADVs to the RAF, with the final aircraft arriving at RAF St. Athan on December 7, 2004. One aircraft was retained for static display purposes. Italian Tornadoes, along with RAF Tornadoes, took part in the First Gulf War in 1991. Operation Locusta saw 8 Tornado IDS interdictors deployed from Gioia del Colle, Italy, to Al Dhafra, Abu Dhabi, as a part of Italy's contribution to the coalition. During the conflict, one aircraft was lost to Iraqi anti-aircraft fire, the pilots ejected safely and were captured by Iraqi forces. A total of 22 Italian Tornadoes were deployed in the NATO-organized Operation Allied Force over Kosovo in 1999. The IDS variant was used in the bombing role while the ECR variants patrolled the combat region, acting to suppress enemy anti-aircraft radars, firing 115 AGM-88 HARM missiles. In response to anticipated violence during the 2010 Afghanistan elections, Italy, along with several other nations, increased its military commitment in Afghanistan, dispatching 4 IDS Tornadoes to the region. Italian Tornado IDS and ECR aircraft participated in the enforcement of a UN no-fly zone during the 2011 military intervention in Libya. Various coalition aircraft operated from bases in Italy, including RAF Tornadoes. Italian military aircraft delivered a combined 710 guided bombs and missiles during the strikes against Libyan targets. Of these, Aeronautica Militare Tornadoes and AMX fighter bombers released 550 guided bombs and missiles, and Italian Navy Avenue 8BS delivered 160 guided bombs. Italian Tornadoes launched 20 to 30 Storm Shadow cruise missiles, with the rest consisting of Paveway and JDAM guided bombs. In July 2002, Italy signed a contract with the Tornado Management Agency in Panavia for the upgrading of 18 IDSs, the first of which was received in 2003. The upgrade introduced improved navigation systems and the ability to carry new weapons, including the Storm Shadow cruise missile, Joint Direct Attack Munition and Paveway 3 laser-guided bombs. Italy has opted to extend the Tornado's service life at the expense of alternative ground attack aircraft such as the AMX International AMX. In 2010 a major upgrade and life extension program was initiated, which will provide new digital displays, Link 16 communications capability, night vision goggles compatibility, and several other upgrades. In the long term, it is planned to replace the Tornado IDS ECR fleet in Italian service with the Lockheed Martin F-35 Lightning II, with the final Italian Tornado scheduled to be phased out in 2025. Royal Air Force. Nicknamed the Tonka by the British, the Tornado made its combat debut as part of the British contribution to the Gulf War in 1991. Operation Granby saw nearly 60 RAF GA-1s deployed to air bases at Murak in Bahrain and Tabaik and Dhahran in Saudi Arabia. Several Tornado ADVs were deployed to provide air cover, the threat of their long-range missiles being a significant deterrent to Iraqi pilots, who would deliberately avoid combat when approached. Early on in the conflict, the GA-1s targeted military airfields across Iraq, deploying a mixture of 450 kg unguided bombs in loft bombing attacks and specialized JP-233 runway denial weapons. 6 RAF Tornadoes were lost in the conflict, 4 were lost while delivering unguided bombs, 1 was lost after delivering JP-233, and 1 trying to deliver laser-guided bombs. On January 17, 1991, the first Tornado to be lost was shot down by an Iraqi SA-16 missile following a failed low-level bombing run. On January 19, another RAF Tornado was shot down during an intensive raid on Tallal Air Base. The impact of the Tornado strikes upon Iraqi airfields is difficult to determine. In an emergency deployment, the UK sent out a detachment of Blackburn Buccaneer aircraft equipped with a PAVE Spike laser designator, allowing Tornado GA-1s to drop precision-guided weapons. A further crash program in support of the sudden military action saw multiple GA-1s outfitted with the TIALD laser designation system. Author Klaus Christian Stmann declared that the TIALD pod enabled the GA-1 to achieve probably the most accurate bombing in the RAF's history. Although laser designation proved effective in the Gulf War, only 23 TIALD pods were purchased by 2000. Shortages negatively impacted combat operations over Kosovo. Following the initial phase of the war, the GA-1S switched to medium-level strike missions. Typical targets for these strikes included munition depots and oil refining facilities. Only the reconnaissance Tornado GA-1S continued to operate at the low-altitude high-speed profile throughout the war. The GA-1A emerged unscathed despite the inherent danger posed by missions such as conducting pre-attack reconnaissance. In the war's aftermath, Britain maintained a military presence in the Gulf for many years. Around half a dozen GA-1S were based at Ali Al Salem Air Base in Kuwait for operations over the southern no-fly zone as part of Operation Southern Watch. Another half a dozen GA-1S participated in missions over northern Iraq in Operation Provide Comfort. In March 1993, a midlife upgrade project of the Tornado was launched to upgrade the GA-1 per grain 1A to GR-4 per grain 4A standard. The Tornado GR-4 made its operational debut in Operation Southern Watch, patrolling Iraq's southern airspace from bases in Kuwait. Both Tornado GR-1S and GR-4S based at Ali Al Salem, Kuwait, took part in coalition strikes at Iraq's military infrastructure during Operation Desert Fox in 1998. In December 1998, an Iraqi anti-aircraft battery fired 6 to 8 missiles at a patrolling Tornado. The battery was later attacked in retaliation. No aircraft were lost during the incident. It was reported that during Desert Fox RAF Tornadoes had successfully destroyed 75% of allotted targets, and out of the 36 missions planned, 28 had been successfully completed. The GA-1 participated in the Kosovo War in 1999. The Tornadoes initially operated from RAF Bruggen, Germany. They later moved to Solnzara Air Base, Corsica. Experience from fighting in Kosovo led to the RAF procuring AGM-65 Maverick missiles and enhanced Paveway smart bombs for the Tornado fleet. Following the Kosovo War, the GA-1 was phased out as more aircraft were upgraded to GR-4 standard. The final GA-1 was upgraded and returned to the RAF on June 10, 2003. The GR-4 was heavily used in Operation Telek, the British contribution to the 2003 invasion of Iraq. RAF Tornadoes flew in the opening phase of the war, flying alongside American strike aircraft to rapidly attack key installations. Following an emphasis on minimizing casualties, Tornadoes of No. 617 Squadron deployed the new Storm Shadow precision cruise missile for the first time in the Iraq conflict. While 25% of the UK's air-launched weapons in Kosovo were precision-guided, 4 years later in Iraq this ratio increased to 85%. On March 23, 2003, a Tornado GR-4 was shot down over Iraq by friendly fire from a US Patriot missile battery, killing both crew members. In July 2003, a U.S. Board of Inquiry exonerated the battery's operators, observing the Tornado's lack of functioning IFF as a factor in the incident. Problems with Patriot were also suggested as a factor. Multiple incidents of misidentification of friendly aircraft have occurred, including the fatal shoot-down of a U.S. Navy McDonnell Douglas FA-18 Hornet a few weeks after the loss of the Tornado. Britain withdrew the last of its Tornadoes from Iraq in June 2009. In early 2009, several GR-4S arrived at Kandahar Airfield, Afghanistan, to replace the Harrier GR-7/9 aircraft deployed there since November 2004. In 2009, Paveway 4 guided bombs were brought into service on the RAF's Tornadoes, having been previously used in Afghanistan by the Harrier II fleet. In summer 2010, extra Tornadoes were dispatched to Kandahar for the duration of the 2010 Afghan election. Prior to the 2010 Strategic Defense and Security Review's publication, the retirement of the entire Tornado fleet was under consideration. Savings of £7.5 billion were anticipated. The SDSR announced the Tornado would be retained at the expense of the Harrier II, although Tornado numbers are to decline in transition to the Eurofighter Typhoon, and later on, the F-35 Lightning II. On March 18, 2011, British Prime Minister David Cameron announced the deployment of Tornadoes and Typhoons to enforce a no-fly zone in Libya. In March 2011, several Tornadoes flew 3,000-mile strike missions against targets inside Libya in what were, according to Defense Secretary Liam Fox, the longest-range bombing mission conducted by the RAF since the Falklands conflict. A variety of weapons were used in operations over Libya, including laser-guided bombs and brimstone missiles. 59 RAF aircraft are receiving the CUSP Avionics upgrade, which achieved initial service date in March 2013, and the type will be withdrawn from RAF service on March 31, 2019. Royal Saudi Air Force. On September 25, 1985, the UK and Saudi Arabia signed the Al Yamama 1 contract, including, amongst other things, the sale of 48 IDS and 24 ADV model Tornadoes. The first flight of a RSAF Tornado IDS was on March 26, 1986, and the first Saudi ADV was delivered on February 9, 1989. Saudi Tornadoes undertook operations during the Gulf War. In June 1993, the Al Yamama 2 contract was signed, the main element of which was 48 additional IDSs. Following experience with both the Tornado and the McDonnell Douglas F-15E Strike Eagle, the RSAF discontinued low-level mission training in the F-15E in light of the Tornado's superior low-altitude flight performance. In addition, 10 of the Saudi Tornadoes were outfitted with equipment for performing reconnaissance missions. The 22 Tornado ADVs were replaced by the Eurofighter Typhoon. The retired aircraft were being purchased back by the UK as of 2007. By 2007, both the Sea Eagle anti-ship missile and the Alarm anti-radiation missile that previously equipped the RSAF's Tornadoes had been withdrawn from service. As of 2010, Saudi Arabia has signed several contracts for new weapon systems to be fitted to their Tornado and Typhoon fleets, such as the short-range air-to-air Iris-T missile, and the Brimstone and Storm Shadow cruise missiles. In September 2006, the Saudi government signed a contract worth £2.5 billion with BAE Systems to upgrade up to 80 RSAF Tornado IDS aircraft to keep them in service until 2020. RSAF Tornado 6612 was returned to BAE Systems Wharton in December 2006 for upgrade under the Tornado Sustainment Program, which will equip the IDS fleet with a range of new precision-guided weapons and enhanced targeting equipment, in many cases common with those systems already fielded by the UK's Tornado GR4S. In December 2007, the first RSAF aircraft to complete modernization was returned to Saudi Arabia. Starting from the first week of November 2009, Saudi Air Force Tornadoes, along with Saudi F-15s, performed air raids during the Shia insurgency in North Yemen. It was the first time since Operation Desert Storm in 1991 that Saudi Air Force partook actively in a military operation over hostile territory. Variants: Tornado IDS, Tornado GR1, RAF IDS variants were initially designated the Tornado GR1 with later modified aircraft designated Tornado GR1A, Tornado GR1B, Tornado GR4 and Tornado GR4A. The first of 228 Grains 1s was delivered on June 5, 1979, and the type entered service in the early 1980s. A total of 142 aircraft were upgraded to GR4 standard from 1997 to 2003. Tornado GR1B. The Tornado GR1B was a specialized anti-shipping variant of the GR1. A total of 26 were converted, which were based at RAF Lossiemouth, Scotland, replacing the Blackburn Buccaneer. Each aircraft was equipped to carry up to 4 Sea Eagle anti-ship missiles. At first the GR1B lacked the radar capability to track shipping, instead relying on the missile seeker for target acquisition. Later updates allowed target data to be fed from aircraft to missile. Tornado GR4. In 1984, the UK Ministry of Defence began studies for a Grain 1 midlife update. The update to GR4 standard, approved in 1994, would improve capability in the medium-altitude role based on lessons learned from the GR1's performance in the 1991 Gulf War. British Aerospace upgraded 142 Tornado GR1S to GR4 standard, beginning in 1996 and finished in 2003. 59 RAF aircraft are receiving the CUSP Avionics package, which integrates the paveway full bomb and installs a new secure communications module from Cassidian in Phaser, followed by the Tactical Information Exchange data link from General Dynamics in Phase B, Tornado GR1 Upper Grain 4A. The GR1A is the reconnaissance variant used by the RAF and RSAF, fitted with the TIRRS, replacing the cannon. The RAF ordered 30 grains 1as, 14 as GR1 rebuilds and 16 as new builds. When the Tornado GR1S were upgraded to become GR4S, GR1A aircraft were upgraded to GR4A standard. The switch from low-level operations to medium-high-level operations means that the internal TIRRS is no longer in use. As the GR4A's internal sensors are no longer essential, the RAF's Tactical Reconnaissance Wing operate both GR4A and GR4 aircraft. Tornado ECR, operated by Germany and Italy, the ECR is a Tornado variant devoted to suppression of enemy air defenses missions. It was first delivered on May 21, 1990. The ECR has sensors to detect radar usage and is equipped with anti-radiation AGM-88 HARM missiles. The Luftwaffe's 35 ECRs were delivered new, while Italy received 16 converted IDSs. Italian Tornado ECRs differ from the Luftwaffe aircraft as they lack built-in reconnaissance capability and use recce light reconnaissance pods. Also, only Luftwaffe ECRs are equipped with RB199 Mk105 engine, which has a slightly higher thrust rating. The German ECRs do not carry a cannon. The RAF uses the IDS version in the SEAD role instead of the ECR. It also modified several of its Tornado F3s to undertake the mission. Tornado ADV. The Tornado ADV is an interceptor variant of the Tornado, developed for the RAF and also operated by Saudi Arabia and Italy. The ADV had inferior agility to fighters like the McDonnell Douglas F-15 Eagle, but it was not intended as a dogfighter. Instead, it is a long-endurance interceptor to counter the threat from Cold War bombers. Although the ADV has 80% parts commonality with the Tornado IDS, the ADV has greater acceleration, improved RB199 Mk104 engines, a stretched body, greater fuel capacity, the AI-24 Foxhunter radar, and software changes. It has only one cannon to accommodate a retractable in-flight refueling probe. Operators. The German Air Force had 121 IDS and 31 ECR aircraft in service in December 2011. In Italy, Italian Air Force had 62 IDS and 16 ECR aircraft in operation in December 2011. Saudi Arabia, Royal Saudi Air Force had 82 IDS in operation in December 2011. United Kingdom, Royal Air Force had 125 grains 4 on GR4A aircraft in use in December 2011. Aircraft on display. While the type is operational, some older aircraft are on public display. United Kingdom 2946 Tornado prototype pages 2 on display at the RAF Museum Cusford, England. XX947 Tornado prototype pages 3 on display at Shoreham Airport, England. XZ631 Tornado GR4 on display at Yorkshire Air Museum, Elvington, England. ZA319 Tornado GR1T Gate Guard, Mod DSDA Uncot, Bicester, England. ZE887 Tornado F3 on display at RAF Museum, Hendon, England. ZA457 Tornado GR1B on display at RAF Museum, Hendon, England. ZA354 Tornado GR1 on display at Yorkshire Air Museum, Elvington, England. ZA465 Tornado GR1 on display at Imperial War Museum, Dewford, England. ZA328 Tornado GR1 used for apprentice training, BAE Systems Training School, Preston, Lancashire. ZE934 Tornado F3 on display at National Museum of Flight, East Fortune, Scotland. ZA362 Tornado GR1 on display at Highland Aviation Museum, Inverness, Scotland. Germany, D9591 Tornado prototype pages 1 stored at Erding. XX948 Tornado prototype pages 6 on display at Hermskiel. 43+96 Tornado gate guard at the German airbase in Jagel, near Schleswig, Schleswig-Holstein. 44+97 Tornado IDS of the Einsatzgeschwader Mazar-i-Sharif at the Deutsches Museum Flugwaft Schlesien, Oberschleißheim. 44+31 Tornado IDS of the 31st Fighter Bomber Wing Bewilk at Nahe Paragraph Ravennisch AB. Tornado IDS on display at the Luftwaffe Museum, in Berlin. Tornado IDS on display at the Technik Museum Speyer. Saudi Arabia, Tornado ADV F3 on display at the Royal Saudi Air Force Museum in Riyadh. Tornado IDS on display the Royal Saudi Air Force Museum in Riyadh. Italy, MM7210 Tornado F3 on display at the Italian Air Force Museum, Vna di Valle. United States, ZA374 Tornado GA1 on display at the National Museum of the United States Air Force, Wright-Patterson AFB, Ohio. 43+74 Tornado IDS of the German Navy, Marinefluggeschwader 1 at the Pima Air and Space Museum, Tucson, AZ. Bulgaria, 44+13 Tornado IDS on display at the National Museum of Military History, Sofia. Specifications. Data from International Warbirds, an illustrated guide to world military aircraft, 1914 Euro 2000, Tornado. Modern fighting aircraft, general characteristics, crew, 2, length, 16.72 am, wingspan, 13.91 am at 25 a degree wing sweep, 8.60 am at 67 a degree wing sweep, height, 5.95 am, wing area, 26.6 mass squared, empty weight, 13,890 kg, max takeoff weight, 28,000 kg. Power plant, TUA, Turbo Union. RB199-34 MK103 afterburning turbofans, dry thrust, 43.8 kN each, thrust with afterburner, 76.8 kN each. Performance, maximum speed, Mach 2.2 at 9,000 m/30,000 feet altitude. 800 knots, 1,482 km/h. 921 miles per hour indicated airspeed near sea level, range, 1,390 km typical combat, ferry range, 3,890 km with 4 external drop tanks, service ceiling, 15,240 am, rate of climb, 76.7 ams, thrust weight, 0.55, armament, guns, TUA, 27 on Mauser BK-27 revolver cannon internally mounted under each side of fuselage, each with 180 rounds, hardpoints, 4 light-duty plus 3 heavy-duty under fuselage and 4 swiveling underwing pylon stations holding up to 9,000 kg of payload. The 2 inner wing pylons have shoulder launch rails for 2 short-range AAM each, missiles, air-to-air missiles. AIM-9 Sidewinder or AIM-132 ASRAM for self-defense. Air-to-surface missiles, 6 AGM-65 Maverick. Or, 12 Brimstone missile. Or, 2 Storm Shadow cruise missile. Anti-radiation missiles, 9 Alarm missile. Bombs, 5 500 pounds paveway 4. Or, 3 1,000 pounds paveway 2 enhanced paveway 2. Or, 2 2,000 pounds paveway 3 enhanced paveway 3. Or, hunting engineering BL-755 cluster bombs. Or, up to 2 JP-233 or MW-1 munitions dispensers, up to 4 B-61 or WE-177 tactical nuclear weapons. Others, up to 4 drop tanks for ferry flight extended range loitering time. Avionics, Raptor aerial reconnaissance pod, RAF lightning targeting pod. Or, TIALD laser designator pod, BAE Systems Sky Shadow electronic countermeasure pod, popular culture. See also: Future offensive air system, Wild Weasel, Related development, Panavia Tornado ADV, aircraft of comparable role, configuration and era, Dassault Mirage 2000, General Dynamics F-111 Aardvark, Grumman F-14 Tomcat, McDonnell Douglas F-15E Strike Eagle, Microwin MiG-27, Sukhoi Su-24, XCNJ-H-7, related lists, list of active United Kingdom military aircraft, list of military aircraft of Germany, references, notes. Bibliography. External links, Air Force fact files on airforce-technology.com, tornado on faz.org, Panavia Tornado IDS attack bomber on aerospace.org, Panavia Tornado on tornado-data.com, list of all active German tornadoes, German IDS Tornado 44 plus 97 at the Deutsches Museum subsidiary Flugwaffenbeschleunigung, Germany, MRCA, 6 years after TSA-2 a 1971 flight article, Supremacy, Panavia MRCA a 1975 advertisement in flight.